Are you still waiting for your Angular application to load? You are not alone. Slow performance is a common issue for many developers. But here's the good news, there's a simple built in feature in Angular that can make your app up to 3x faster, and chances are you are not using it yet. It is called Defer block, introduced in Angular 17, and it is an absolute game changer. It lets you delay rendering part of your UI until they are actually needed, making your app faster, smoother, and more responsive. In this video, you will know exactly how it works. So, as performance is an important factor in web app development, Defer is one of the Angular feature used to improve the performance. Like in lazy loading, all the components are divided into modules, and we can use the required modules to reduce the time of initial load. In this application, as you can see, only first two components are visible to user at first. Rest are shown when user scrolls the page or interacts with it. So to lazy load these standalone components, defer directive is used. To defer the loading of the specific part of the website, defer is used. So let us start with the requirements. As this defer feature is introduced in Angular 17, so any version later than Angular 17 can be used. In this, I have used Node.js version 20 and Angular CLI's version 18.2.19. So, once your Node.js installed, you can proceed with Angular CLI. To install the Angular CLI, command that you can use is this. If you want to use a if you want to use command with specific version, what you can do is write @ after this and add the version name that you want to install, and you can use that command. So after that, you should create a Angular project with the command using ng-new test angular defer, in which test angular defer is the name of my project, as you can see here. So next is structuring the application. So let me show you how I made the structure of this application. So I have created a layout component, and in the layout component I have added header and footer. So I will create nested routing in which I will create a layout first containing header and footer, and in that layout I will add router outlet so that I can use these components in it. I have created about component, home component, services component, and spinner component. So these were the components I have created. So as you can see, the list of the components are here mentioned. So to create these components, commands are also mentioned. First of all, we have to open app component, ts, and as you see, router outlet is imported here, and in app component html I have removed the welcome component and added the router outlet here, which is the first step. And for next, I have already informed you about the project commands needed. Next is creating the layout structure. So for layout structure, in layout component, first of all, in TypeScript file, I have imported header component, footer component, router outlet, and spinner component in it. The spinner component I will use it later. So in its HTML file, to create the layout, first of all I have added header, and at last I have added footer, and in between I added router outlet, like this. Next is configuring the routing in the application. So to add the routes, I have added in approutes.ts, in which I have implemented nested routing, in which I have added layout component as parent component and home component as its child component. And to redirect the page, I have redirected it to the home. So as you can see in the application, on loading the application, it is loaded onto the home page. Like for example, if I open localhost 4200, it is redirected to the home page. And in home page, first we have added layout. So due to the layout, header is shown, and at last footer is shown. So let's see how about us and what we provide is shown. So for that, I have added home route for home component. So let's move on to the home component. In home component, I have imported services component and about component and spinner component. In spinner components working I will show you later. So in home component, I have added about component app selector and services app selector, which is shown here. About us component, and in services component I have written what we provide. If you want to see, like this. In about component I have added about us, and in services component I have added what we provide. So let's talk about the CSS. For global CSS, I have added classes in style.css. So I have created a box class which is common for all the components. As you can see, there is common styling for header box, about, what we provide, and footer, which is added in the box class. And for the different color and heights, I have added the CSS in their component CSS file. For example, in header CSS, I have added background color and height, and same in other components also. So let's see how defer works, how you can enhance the performance with defer directive. Angular's defer syntax introduces a powerful way to load the components conditionally only when they are truly needed. So let's open home component, in which I will show you how defer works. This reduces the size of initial bundle, speeds up the load time, and improves overall application performance. So how defer works? As you have seen that I have added the component selector for services component like this. So for using the defer directive, I have to remove this and add the component selector like this in defer directive. As you can see, it works like this. So defer the loading of a component until a specific condition is met, such as scrolling, interaction, or visibility on the viewport. This defer directive tells Angular package that services component into a separate JavaScript bundle loaded when needed. You will notice a separate chunk in the build output representing a deferred content. So as we have added this, due to which when the code compiles, as we compare it to the earlier thing, this time as in earlier, only initial chunk files were created and its size were 9.93 KB. But after adding the app services component to defer directive, its size is reduced and lazy chunk files are created. This will reduce the time and load. So its size is reduced. So let's see. Is there any visible difference? So it will load after the user scrolls to it. So in defer, there is another thing called placeholder directive. Angular allows you to show a placeholder while the deferred component is being loaded. So let us update our layout component with this. There's a example of using the placeholder. So this will be implemented on footer component like this. So the loading panel looks like this. You can enhance user experience with this. So the placeholder is shown until the actual component footer is shown, but you didn't see a visible difference. If you want to see a visible difference, you can add a minimum duration to it. Like for example, I have added a minimum duration of 4 seconds to it. So let's save it and check this. So after loading, as you can see, loading panel is shown, and after some time, which is actual 4 seconds, after 4 seconds the footer component is shown. So this is how placeholder works. Next is using defer with loading a spinner. So first of all, for this we have to create a spinner. Let's see. So I have created a spinner component which I mentioned earlier, in which I created a parent for spinner box and the spinner. So the styling for it is this. So for parent I have added width, height and padding, and for spinner I have added its CSS and created an animation in round motion. So in the component we can see loading like this. I have added this to footer component. So I have commented earlier component selectors, and now I have added the loading component, loading directive to it. Like this. Again, if you want to see a clear difference, what you can do is add a minimum duration to it and see how spinner works. So let us increase its time to clearly see it. See, this is how spinner works and the component is shown. Let's see its another example in home component. So first of all, we comment it, and in home component I have added this same to services component. You can see as well. Wait a minute. So I haven't commented this first of all. Like this. You can see this component loads now. So after this, let's move to the layout component. So the next is handling errors with defer. How you can handle errors with defer? For that, defer provides an error directive which you can use if any error occurs in the case the component loads. You can add the error directive and add the div which you want to show or any kind of message in case error occurs. So next is triggering defer load conditions. So let's see how it works. You can control when Angular should begin loading as a deferred block using specific triggers. Using this you can control defer block. So first of all is the idle condition, as we have seen it earlier. So it loads after browser finishes loading all other resources. Next, let's move on to the next. So next is on viewport. So it means it loads when the component became visible to the viewport. So the component is loaded when it becomes visible to the viewport. So like this. So as I scroll the page and this footer component became visible to me, then it is loaded. So let's comment this and add the simple component selector of it to see the clear difference. So next is on interaction. This will make you more clear. So as you see, loading panel is shown. Until I interacts with it, the footer component won't be loaded. So how you can interact with it? By clicking on it or by typing. As you can see, I have clicked on it and then the component is loaded. Next is hover trigger, in which it loads on the mouse over. So like this, when I will move the mouse over it, the component will load like this. Next is on immediate. So this is interesting. It loads immediately but still in separate chunks. So if you want to load the component immediately but you also want to improve its performance, you can use on immediate. So it loads immediately but in separate chunk. Next is on timer. In this you can provide a specific timer until which the component loads, like writing it like on timer and providing the time in it. So I have provided the time 2 seconds. So let's refresh it. uh, let's do it once again to see the difference like this. After 2 seconds the component is loaded. These triggers give you fine-grained control over how and when resources are loaded, optimizing the performance for different user behaviors. So there's another thing called when condition. So using this when condition, writing the condition here, you can load the component based on that condition. If the condition is true, the component will be loaded. So as you can see the conclusion here, once defer is implemented, the benefits become visible to your build artifacts and loading performance. In key metrics to observe are initial bundle size, load time, and deferred chunks. So, defer syntax in Angular provides powerful declarative way to boost application performance. With support of diff loading strategies, placeholders, spinners, error handling, and trigger-based rendering, it ensures a smooth user experience and optimized loading behavior.